there, students. Mr. Lawrence here with your flipped lesson, and we are going to do a little bit of a review of the things we've covered. I'm not going to do every one of these types of problems. Some are going to be built into others, but let's get down to it because this is going to be a little bit of a longer video. Now, by the way, some of you know when there's a quiz coming up, like you don't prepare. You need to go back and watch a video of something you're weak on. For example, let's say hypothetically Logan was really weak on GCF. Well, Logan could go back, watch the video again on GCFing. Or, if, I don't know, Nellie was weak on the difference of perfect squares. She could go back and rewatch that video, take some notes, and then do some practice problems from her book. If you want to be successful, you have to do whatever it takes so that you can be successful. You can't just try to get by anymore. The material's getting too difficult. You notice your grades are dropping. Uh-oh, that was strange, but everything seems to be okay. Okay, enough preaching. Let's get on with some practice problems. Now look, problem number 1, 3x plus 5x. How many x's do I have? Well, I have 3 x's here, and I have 5 x's here. How many x's do I have? I have 8 x's. 3x plus 5x equals 8x. And I'm done. Doesn't equal 8x squared. And, I don't know what you guys were thinking on that quiz last week. It was crazy. Now look at this one. 6x squared plus 5x cubed plus 3x squared. This does not equal 14x to the 7th. It doesn't equal that. That is wrong. Look, you guys are better than this. You know that you have to combine like terms. I didn't see a single person using a highlighter. I did see some people. It might have been Jacob and Nicole's group. I think they might have been kind of doing something like this. Or maybe it was Austin. Somebody who sits near that area of the room was doing that. And I think that's a really intelligent idea. If you don't use the strategies I show you, why are you surprised that you're getting it wrong? 3x squared and 9x squared, or 6x squared gives me 9x squared. The 5x cubed just comes along for the ride. They're not like terms. The exponents have to match. Did you hear that, Jake? The exponents have to match. Kayla, were you listening? The exponents have to match for me to be able to add. Hey, Alex, did you hear that? The exponents have to match. Anna, the exponents, what do they have to do? Match. Okay. These exponents don't match. I can't add them together. Adding is counting like things. That's all it is, like things. And those are x squared things, and those are x cubed things, and they don't match. It's kind of like counting fire trucks and police cars. You can make the x squareds the fire trucks, and the x cubes the police cars. You can't bash them all together, okay? All right, let's see here. Now, let's try this in a big addition problem. You know what? I'm going to first look and see its addition. Right? You see the addition sign? This is not a FOIL problem. We are adding. FOIL is a multiplication thing. I've only said that in class like 800 times. So I'm going to go and look and see. I've got x to the 5th. Any x to the 5th over here? I sure do. Okay. I've got x cubes. Any x cubes? Yeah, I got x cubes. Make sure I grab that sign. Oops, I didn't grab the sign there. Sorry about that. Okay. I've got plain old x's. I've got plain old x's. Now this 3 guy, 3x to the 4th, he's by himself, isn't he? Now all I'm going to do is I'm going to combine the like terms. If you don't want to use highlighters, then do this little thing. Those two are going together. How many x to the 5th do I have? I have 14x to the 5th. So I'm just counting how many of these guys I have. 6 here, 8 there, 14 of them. Okay, and then my x cubes can go here, except I've got 2x cubes minus 2x cubes. They completely cancel. In addition, canceling is 0. Say that again. Addition, canceling is 0. In addition, canceling is 0. In addition, canceling is 0. In addition, canceling is 0. Multiplication, canceling is 1. So there's not going to be an x cubed term. I've got this x to the 4th term, That's all by himself, so I'm just going to write him down, 3x to the fourth. And now I'm going to combine these two. And I've got a negative 3x and a positive 7x. Well, 7 minus 3 is 4. 4x. And there you go. All right. Run thing right here. You see this negative? Do you see it? Where'd it go? Oh, wrong one. I need my highlighter. Where's my negative? Where's my negative? There he is. What do I need to do with that negative? I need to distribute him. Distribute the negative. Distribute the negative. Distribute the negative. I am distributing the negative. Now I can go and combine my like terms. Very few people saw to do that. Okay, I've got x squareds minus 10x squareds. I've got plain old x's. I've got plain old x's. I've got number, a plain old number. All right. So I'm going to combine my greenies. 12x squared minus 10x squared. 2x squared. 8x. 5x. 13x. Negative 7. Negative 7. Negative 14. All right, let's get on to the factoring. Okay, let's see here. Good, we're doing well on time. All right, see this binomial? First type of factoring? GCF. GCF. The GCF, I believe, is going to be 16. I'm going to pull a 16 out, and I'm going to have an x to the fourth minus 4. But wait, there's more. You see inside that quantity there? Inside that quantity, I have the difference of perfect squares. Now, this 16 16 is going to come down, but this quantity is going to break up into two quantities. So I'm going to have a 16, and then I'm going to have two quantities. Remember, quantities break up into two or more things, always, not just one. So let me see here. I got a perfect square. The square root is x squared. I've got a perfect square. Squared is 2. So here's how it breaks up. X squared plus 2, and then x squared minus 2. Now I'm going to check and see if I can break these quantities up more. I know the 16 is done. X squared plus 2 is the sum of perfect squares. I can't do anything. X squared minus 2. Well, it looks like the difference of perfect squares, only 2 is not a perfect square. This problem is complete. There are no more steps to it. Okay, moving on to trinomials. Now, I'm not going to start with the lead coefficient 1. We were just talking about perfect squares. Look at that. 81x squared is a perfect square. 9x. 25 is a perfect square. 5. Multiply those two together, and I get 45x. If I double that, I get the middle coefficient. This is a perfect square trinomial. 9x minus 5 times 9x minus 5. There we go. There we go. All right. Now I've got a trinomial with a lead coefficient of 1. I look at the last term. I take its factors. 81. 2 is not going to go in. 3 is going to go in 27 times. 4 won't go in. 5 won't go in. 6 won't go in. 7, 8, 9 is the only other one that goes in. Now I look here. This is a positive. So I'm going to add 2 of these factors to get the middle number. And remember, there's a plus in the back. That's the Wendy's double stack. Hold on. I'm having a little trouble with my pen. All right. So I know it's going to look like this. And I know they're both going to be negative. How do I know that? There's a plus in the back. It's the Wendy's double stack. That sign shows up twice in both quantities. Okay. So I need to add 2 factors of 81 to get me 30. Bam, right there. here's the same type of only it's a minus in the back. Well, I'm going to list the factors of 60, 20, 4 and 15, 5 and 12, 6 and 10, 7, 8, 9 don't go in. Okay, now, when there's a minus in the back, I'm going to subtract. A minus in the back means you subtract. A minus in the back means you subtract. All right, so I know that I'm going to have something like this because the lead coefficient is 1. And I'm going to have a plus and a minus. Now I'm going to subtract to get 7. Okay, and where will the negative go? Well, see this sign here in the middle? This sign will go on the larger factor. So I can say 12 and 5 can subtract to get 7, 12 and 5. But since the middle coefficient is negative, the 12 is negative and the 5 is positive. All I do is write minus 12 in there and a plus 5, and I am done. All right, 2 more. Trinomials where the lead coefficient is not 1, I multiply 15 times 2, and I get 30, so I'm going to list the factors of 30. 2 and 15, 3 and 10, 4 doesn't go in, 5 and 6. Hold on 1 second here. Do I have a small mistake? No, I'm good. I'm good. All right. Now on this one, I need to subtract to get 7. I need to subtract to get 7. Well, 10 minus 3 is 7, right? I'm going to rewrite this 15x squared. There's going to be a minus 2 at the end, but I'm going to break that plus 7 up into 7x into a 10x minus a 3x. Okay? And I'm going to try to group them together so that I have GCF. So I'm going to put the minus 3x there and a plus 10x there because I see a GCF in both. Now I've changed it into a 4-term polynomial, and I take a GCF out of here. Looks like it's going to be a 3x, 3x, 15x squared. Well, 15 divided by 3 is 5. X squared divided by x to the first is x. 3x divided by 3x is 1. It cancels, but it's using division. Canceling using division gives a 1. Canceling with division gives a 1. Canceling with division gives a 1. Canceling with subtraction or addition gives a 0. But canceling with division gives a 1. All right. Now, here my GCF looks like it's going to be a 2. So I'm going to pull a 2 out, and I'll have a 5x minus a 1. And then I can say 5x minus 1 times the quantity of 3x plus 2. Okay, one more problem. Same type of problem. I'm going to multiply these two, get 42. I'm going to do 2 and 21. I believe 3 is going to go in. Let's see, that'd be 14. 4 won't go in. 5 won't go in, but 6 and 7 will go in. Okay. There's a minus in the back, means I subtract. All right, so I've got to subtract to get 19. And remember, this sign goes to a larger coefficient. So I've got 21 and 2. And if I do a positive 21 minus 2, that's a 19, isn't it? So I rewrite this 6x squared, a minus 7 at the end. I break that 19x up into 21x minus 2x. Where do I put them? Well, I think I'm going to put the minus 2x with the 6x squared and the plus 21x with the 7. Okay, I'm ready to group. It's grouping time. Break it down. All right. Divide by 2x by 2x. That's my GCF. I'm going to get 3 minus 1. Oh, 3x minus 1. And here my GCF is just going to be a 7. So I'll pull a 7 out. And I'm going to get a 3x minus a 1. I'll get a quantity of 3x minus 1 and a quantity of 2x plus 7. And that's it. I am done. All right, Mr. Lawrence signing off. Good night, everybody.